Welcome to today's lesson, and today I want us to cover vectors. Vectors 1, and we start with introduction. So, to understand what is a vector, let me draw a line here, the compass here. So that's a compass. We have that, and we have this is north and this is east direction, and then we have another point here which is B. We can say we have a point here B, and this is our point A, and this angle is the angle here is 0.45 degrees. Now we need to describe B, and it is 50 kilometers from A. So we can describe B in reference to A and say B is 50 kilometers from A. B is 50 kilometers from A. That is one way we can describe B. The other one is B is northeast of A, so we can say B is northeast of A, and we have the other one is we can describe is B is 50 kilometers northeast of A. So the third one best describe position B. Why? Because it specify the distance from A and the direction. So when we describe so this is what we call a vector. So a vector is a unit, or we can say a vector describe a magnitude and direction of a quantity. Direction of a quantity. So you can say Roman number 3 describe a vector. Example of vector include velocity, it includes acceleration, it includes force and others. So then we can say a quantity that only has magnitude, that has only magnitude is called a scalar. Example of scalar is mass. Weight is a vector. Then we have distance, and we have temperature, we have time. So in summary, we can say that a quantity that have magnitude is the same as size, and magnitude and direction is known as a vector. A quantity that has only magnitude is known as a scalar, and we have given examples of that. Next, we look at representation of vector. representation of vector. Now, a vector, since we have defined a vector to be represented by a magnitude and direction, when you draw a vector, you must indicate the direction. For example, if this is vector AB, then it has direction. Then it has magnitude. So a vector normally has a vector, a magnitude and direction. Then we can call this vector A, or we also use A with a zigzag line underneath. So whenever you see this zigzag line written in this kind of way, then you understand it is a vector. So when you draw a vector, you must indicate the direction. You must indicate the direction. From there, we look at equivalent vectors. We look at equivalent vectors. Now, equivalent vector, we say that two vectors are equal if they are facing the same direction and have the same magnitude. For example, if I draw a vector like this, and I call it, okay, I have shown the direction, then I call it, I can call it vector A. Let me show you, vector A. So that vector, we can call it A. Now, if I make another vector here, which is the same as A, and I call it vector B, you can see that vector A and vector B are facing the same direction and they are equal in magnitude, because what I have done here, I have duplicate vector A. So we say two vectors are equal, if they have the same, if they have equal magnitude, and same direction. So I hope that is clear. When we are representing the magnitude, we use two vertical lines. For example, the magnitude of vector AB, like that. That is, these two lines, two vertical lines, represent the magnitude. So in this case, we are saying the direction of A is the same. So we have, and the magnitude of A and B are equal. So that is how we represent the magnitude. From there, we have addition of vectors. Addition of vectors. We have addition of vectors. Addition of vectors. Now we can add two vectors. So we can have, let's say, a vector here. So that's a vector, and we can call it vector AB. Let's call it vector AB. So it shows the direction and the magnitude. So that is vector AB. Then we can have another vector here and call it, we can call this vector, let's call this vector BC, and this is the direction. So that's another vector that, so when you add vectors, then what do? You bring this vector here and you put it. So when you add two vectors, they form a vector from A to B to C. Then we can have now one vector which is a combination of the two, and we have, this is now the vector that which is a combination of two. Remember, in vectors we describe a vector describe movement. So when you add, actually if we say this vector is A and this vector is B, then this vector is A plus B. So that is how we add vectors. That is how we add vectors. So if you have a vector here, we put a vector there, a vector there. These are two vectors. You can say this is that's a vector. We can say this is A, this is B. Then the resultant vector, or the addition of the two vectors, this vector is vector A and B, A plus B. So that is how we add two vectors. From there we have, we can have an example. Let's say we have, so that is generally introduction of vectors. So let's have examples here, and they say use a graph paper to illustrate the sum of the following vectors. So we have example. Our example says use use graph paper. Use graph paper to illustrate the sum of the following vectors. And we have A plus, we have, let's do another example. I don't think we need. Example 1, we have vectors here, A, B, C, and D. So we have vector A in that direction. So we can say, you can say the direction of A and B are not the same. So A is not equals to B. What about vector C, this vector here? They are equal in magnitude, but they are opposite in directions. So A and D are in opposite direction. So they are not equal. Then we have E and F. Same direction, same magnitude. So we can say E and F are equal, or what we are calling equivalent vectors. So that is just an introduction of what is it about. We also look at zero vector. We look at zero vector. So zero vector is when we have two vectors which are equal but different, facing different direction. So for example, we have a vector, we can have vector A. That vector, we can name it A, and we can have another vector B, that is 1, 2, 3, 4, 5, 6, 7. So we have another vector B, and you can just let's Let's duplicate this one. So let's say we have this vector B, so we can label this vector B. So you can see A and B are equal in magnitude because actually I have duplicated, but the different direction. This means that if you bring B on top of A, they will cancel each other. What does that mean? It means that vector A is equals to minus vector B, and therefore we have A plus B is equals to 0. A plus B is equals to 0. That is what we call zero vector. So zero vector is that. From there, we look at multiplication. We have multiplication of vectors. Multiplication of vectors. Now, let's create a vector here and call it our vector A, like that. So that's vector A, and we can call it vector A. Now, suppose we have another vector like this one. We can duplicate that. And we have 3 vectors. So we have our vector A, our vector A. If we combine these 3 vectors, so we bring our A here, we take our A there, so that's another A. We take this other vector there, and we say it is our A, so we have combined. This means that if we label this vector A, and A, we have B, we have C, we have D. We can say that AD, now the complete vector AD is equals to A plus A plus A. So that gives us what? 3A. 3A. Remember we say that we can use that as to mean or to indicate it's a vector. So when you write a vector, that is, for example, PQ is equals to K vector B. K is known as a scalar. We call it scalar multiple. So here 3 is a scalar. We have multiplied that vector by 3, so 3 is a scalar. We have a negative scalar. We have a negative scalar. That is, when you have a vector, you can draw a vector here. We have a vector which we can let's put that. So this vector, we can label it B. So if we duplicate that vector, we can have another B. We can have another B. So this is vector B. This is vector B. Now, suppose now we rearrange our vector like this. We rearrange our vector like this. We arrange it like that. Let's put that together. I think it is giving me problems. So we just come here and say so that is our vector. So we make another vector B, and we make another vector B. So that means that those are 3B. Suppose now we say this is our vector A, we have B, we have C, not C, not there, we have C, and we have D. if we change the direction of this vector like that, change the direction of that, we change that, we change that. Now you see what has happened. Our vector A has changed the direction. So now if we describe our AD, it is equals to minus A, because we are moving from this direction A to D. Then we say it is minus A plus minus A plus minus A, which is equals to minus 3A. So A3 is referred to as negative factor. Negative scalar, not factor, negative scalar. So when the number multiplied by a vector is negative, then we refer to it as a negative scalar. I hope that is clear. Then before I move again, we have, let's just do it, this is a negative scalar. Then we have zero scalar. Not like that, zero scalar. Zero scalar is when we multiply a vector by 0. So we have A, 0 multiplied by, this is 0, is the same as A multiplied by 0 is equals to 0. So when you multiply a scalar a vector by 0, then that is when we have 0 scalar. Let's have an example. We have, let's say, example, we can say, we are going to look at an example here. So we say, this is example 1, vectors A and B are given below. Use a grid to construct B minus A. Use the grid to construct we have A, B minus A, and we have B 3A minus 2B. Okay. Now with that, let me check whether I'll be able to get a graph which will help us to do that. So that is my graph, which I'm going to use to construct that. So let me make it a bit smaller so that it fits on my board. So we can have vectors. Let's say we have vectors like that, and we have a vector like that. So we call this A, this is vector A, and this is vector B. Let me combine them so that I can be able to work as a single unit. So we now bring our grid again, and those are the vectors that we have. So you can see, so we want to construct. So we can, what we can do is that, suppose we are told B minus A. So we have B. We can take now B here at that is we can construct this is A, and we can put it like that. So the vector that you end up with is like that. Remember, this is A, this is B. I think this is B. So this is B. So we want B minus A. So we have B minus A. Then we have our vector here is this. So this is a vector B minus A. B minus A. So that's how you construct that. The other one is 3A. The 3A, what you do is you multiply. You multiply this 3A. So you have a vector, you combine them. We can make it, let's make A a bit smaller so that we can be able to work with it. And we can remove this. So we have our vector A, which we can put it there. And we can have I think that is better. We can have another vector here, which is vector B. So that is vector B, and can combine this. Not like that. Then we bring back our grid. It is like that. We can bring our B there. So when we are told 3A plus 2B, you can combine this. You can say this is our A from here, and we put this other A here, and we put another one there. Okay, and then we have 2B. 2B you duplicate like that, you combine like that. Now we have 3A, so we can now bring our B here, and therefore the vector that will represent this will be the vector that will present 3A minus B. So this is what we have, 3A minus B. So that's how you go about it, and that brings us to the end of that lesson. So let's go to lesson 2. So here are practice questions you can use. We can call them practice questions. So practice questions, you can say number 1, given that T is equals to 2A minus B and R is equals to B plus 3A, find in terms of A and B. Find in terms of A and B. Can put that to denote that they are vectors. The following vectors. So you have A, 2T, B, we have a half R, we have C, we have minus T, we have D is equals to minus 2R, let's remove that. We have D is minus 2R, E, we have 2T minus 2R, we have F, we have F, we have minus T plus a half R, that is FG, G we have 2R minus T. So you can write those vectors in terms of A and B. Then we have another question here. We can say simplify. We have A, we have 3A plus 2B minus C plus 4 into bracket a half A minus 3 over 2 C, then plus a third 6A minus 9B. You can simplify that. You simplify that by putting the right terms together. You can see we have, here we have A. Here we open the bracket, we have A, and here we have A. So you put those A's together. We have B, we have also B here. We have C, we have C. Put those right terms together. Then we have B, we have 2U minus 3V, then plus 2 into bracket W minus U plus 3 into bracket U plus V. You put the bracket. Then we have C, P, put the bracket minus Q plus R minus P plus Q minus R. So you can try those three questions. Remember, this is introduction of vectors, and you have to understand the basics of vectors so that you can be able to get vectors. Even when you get to vectors in Form 3, you have understood the basic. So the next lesson we are going to deal with column vectors and position vectors. And then you see what are position vectors and column vectors. In this part of vector, we are going to discuss the column vector. And column vector is very important in vectors. Once you understand the column vector, we are going to use it for the whole of the lesson, or the whole of vectors, even vector 2 in Form 3. So what is column vector? Column vector represents the displacement of a vector. We said a vector is a displacement. I'm going to use a Cartesian plane to demonstrate that. So let me draw a Cartesian plane here. So we have the Cartesian plane, we have the y-axis, and we have the x-axis here. So we show the arrow there, and then we have our x here, and we have our y there. Now, when you draw the Cartesian plane, you must label. So we have 0, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we are going to use a Cartesian plane to demonstrate what is a column vector. We are going to take 2 points, and these 2 points on the Cartesian plane, we will take A, which is 2, 1. So you read 2 and 1. That is where we have our A. It is coordinates 2, 1. And when we have B, which is 4, 7, so we take 4 and 7. That is where we have our B, 4 and 7. You join the 2 points to come up with a vector. And when you have a vector, we said you must always indicate the direction. A vector has a direction and magnitude. So we want to get the column vector AB. What is our column vector AB? What is going to help us are the components. What are the components? you can see in A, x has changed from 2 to 4. So you can say, if we draw a component here, that to mean A has changed from 2 to 4. So how many units do we have here? We have 2. Then if you look at the Y, it has moved from 1 all the way to 7. So if we draw a component there, then we have this is 7. So we can say, in terms of displacement, then the vector AB is equals to, it has changed. The x component has changed to two components, and no, here it is, here let's correct this. We have here it is 7. It is 6, not 7. So 1, 2, 3, 4, 5, 6. So here we have 6 units, and therefore we say this is 6. So column vector describes the displacement our vector has, that is displacement from A to B. And how do we get that? We get AB, we get the x change in x, which is 4 minus 2, and change in y, it is 7 minus 1, and that is how you are getting 2 and 6. So that is how we get the column vector. Now, if the displacement you see the displacement here is to the right. So, actually, we can put to the right. So when it is to the right, then we say it is positive. That is to the right. That is x displacement. When it is to the left, then it is negative. That is to the left. To the left. I'm going to show you how that happens. Y displacement. In this case, it is upward. So when it is positive, upward, and negative, downwards. So that is how we describe the displacement. Let me use another example to demonstrate this negative and positive displacement. So what we do, we can still use the same diagram. Just make a duplicate of it, and we make 2 other points. Now let's say we have 2 points. Here it is P, and here it is Q. So we can get the coordinates of P and Q. P is at 2, 9. So P is at 2, 9. What about Q? Q is at 8, 2. So Q is at 8, 2. Now, when we get PQ, we join the 2 points to come up with a vector, and this is the direction of the vector. So what here we mean is that PQ is equals to, we draw the components. Let's draw the components here. That's the component, and this is the component of y. So that is the direction of our component. We can get the units here. So for x, it is 1, 2, 3, 4, 5, 6. So it is 6, which is the same as 8 in Q minus 2. And then we take 2 minus 9. So you see here we get what? We get 6. 8 minus 2 is 6. 2 minus 9 is minus 7. So you can see now the displacement of y is to the negative direction. That is why we have negative 7. We can take another vector, which is, we can say, let's take 2 points. Let's take that point to be our M, and we take this point to be our N. So this vector, we can join it. And get the vector Mn. That is the direction. The coordinates of M are, we have said, it is 10 and 8. And N, it is 5 and 7. So we say Mn. Mn is equals to, now we take, x has changed from 10 to 5. So we say it is 5 minus 10. And the other one has changed from 8 to 7. So we say 8 minus 7. So this gives you what? 5 minus 10 is minus 5. And this is 1. So here we have, this is negative. That is a negative displacement of x. Of x axis. Now the other one, this one is negative of in y-axis. In y-axis. So that is why I said when we have displacement downward for in y, then the displacement is negative. Here we have, actually here we have not indicated the displacement. We can indicate this as our displacement. That is our displacement. So you see now here it is x is to the negative, but y is upward. It is changing to the upward. So that is what the column vectors are. Having learned that, we have meaning that if you are given, it is not a must that when you are expressing the column vector, you always draw the Cartesian plane. Let's see, if you are given 2 points, for example, you are told AB, you are told A, the coordinates of A are 3, 5. The coordinates of B are 6, 7. So you can get the vector AB is equals to, you take 6 minus 3, 6 minus 3, and you take 7 minus 5, 7 minus 5. That will give you what? 3, 2. So that is this is what we call column vector. Vector. Think here we left letter N. Here we left letter N. So here we have column vector. So that is a column vector. I think column. Let's put that. So that's okay. So we now have the column vector. So that's how you get the column vector. If you are given P is 5, 2, Q is Q, you say it is you say you can even use a negative 4, and 9. So you can get PQ is equals to, you get minus 4 minus 5, and you get 9 minus 2. So that gives you what? Minus 9 and 7. So getting a column vector, you use a coordinate. What is important to note is that column vector represent displacement. From there, let's do an example. So we have an example. So you are told find the sum of each of the following. Column vector. So you have column vectors, and illustrate their solutions graphically, and illustrate their solutions graphically. Now you understand what is a column vector. We are told that we have A is vector A. We can use that to indicate the vector. It is 2, 3. So that's a column vector. B, and we say, and B is equals to 7, 1. So those are column vector. We have part B. We have, we can use that to indicate it's a vector. We have C is equals to minus 4 and 2. We have D is equal, and D is equals to D is equals to 5 minus 2. Now, so when you are adding this, so here we can say A plus B and C plus D. How do we do that? What we do is that we say that since A plus B, let's delete this. I don't need that. So the sum of these two vectors, A plus B rather, not D, B is equals to 2, 3. You add 7, 1. Okay? So you add the corresponding components. 2 plus 7 will give you 9. And 3 plus 1 is 4. We can illustrate this graphically and say, since okay, let's draw the Cartesian plane. Let's have a Cartesian plane here. So this is our Cartesian plane. We have our x is 9, so, and y the highest value. Okay, let's go that. So we label our Cartesian axis. We say it is y, it is x. So this is 0. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8. We have minus 1, minus 2, minus 3, minus 4, minus 5. Now, if we go back, we have said that let's have this. So this is what we have. I want to put it here. So we have that is what we have done in the previous page. So we have said A and B. So A, we can demonstrate A using we have 2 and 3. So the displacement we can draw it. Let's use a different color. So we can say along the x-axis we have 2 units. Along the y-axis 3 units. So that is our vector A. So that is our A. Then we have B. B is we have 7 units. 1, 2, 3, 4, 5. Let's remove this. So we have 7 units. We have 1, 2, 3, 4, 5, 6, 7. How many units? 1 along the y-axis. So that is our vector B. So this is our vector B like that. So when you add the two of them, then you have, this is A plus B. That is a combination of vector A plus B. And as you can see, we are talking of 9, 9, 9, 4. You can count along the x-axis 1, 2, 3, 4, 5, 6, 7, 8, 9. Along the y-axis 1, 2, 3, 4. So that indicates the sum of the two vectors. We go back and see the other one. The other one, we are told we add C plus D. So C plus D is equals to minus 4, 2, and plus 5 minus 2. So that will give us what? Minus 4 plus 5. That will give us 1. 2 plus minus, that is 2 plus minus 2. That gives us 0. That will give us 0. So we can demonstrate that on the Cartesian plane which we have. We can use this. We can say, let's put that on our page here. This is what I'm going to do. Then I move to my page, and then I bring that to here. So that is that. Now we can be able to, we can pick that point at, so we say A, our C, we can even use this side here. It doesn't matter. So we have minus 4. So we can take x is to the minus direction. So we say that we have said that x is minus 4. So we take 4. We move to the left. 1, 2, 3, 4. So and 2 to the 1, 2. So that is our vector C. So this is our vector C. We can put it, so this is our point C. Then we take our D. Y is in the negative, so we say positive. 1, 2, 3, 4, 5. How many units to negative? So we move downward. 1, 2. So that is our vector D. So this is our vector D. So meaning that we can, this vector A plus D is that vector. So that is what will give us A plus D. A, that is A plus D. And A plus D we have said it is 1, 0. So as you can see, it is 1 unit displacement in the positive direction of x, but 0 displacement. It is horizontal. It is parallel to the x-axis. So y-axis. So it does not have any y displacement, and that's how you get that. I hope that one is clear. Finally, we have we can take another example. Let me give you another example. So we have example 2. Example 2. Now, example 2, we are told if A is equals to 3, 2, and B is equals to 1, 4, then find 3A plus B plus 2B. In this example, we have not been told to illustrate using the Cartesian plane. So you just say solution to this is now we have 3 A is equals to 3. We insert our A, it is this one, 3, 2. So we open the bracket. So 3 times 3 is 9, 3 times 2 is 6. Again, we have our 2B is equals to 2. Our B is 1 and 4. We open the bracket, and 2 times 1 is 2, 2 times 4 is 8. This means that if we add the 2, then 3A, plus 2B will be, our 3A is 9, 6, plus 2, 8, our 2B, this gives you what? 11. That gives you 11 and 14. So that is a vector. That is the sum of the two vectors. And you get that as a solution to that. So I hope now you understand what is a column vector, and it is very important. I have said it is very important. Column vector, as we are going to deal with in 2 dimension and in 3 dimension. So if you have any question, you can always put it in the comments. I will be able to respond. Now, I want to give you a question which you can try and see whether you will be able to do that. So, practice question. So you are told practice question. So you are told if A is equals to 3, 1, comma B is equals to minus 2, 7, C is equals to 6, 5, and D is equals to 0 minus 5, find. We are told to find A, Roman number 1. You say 3 plus 2B, 3 plus, 3A plus 2B. Very similar to what we have done in our example. Roman number 2, you'll be able to find 5B minus 3A. Then we have Roman number 3. You get a half C minus 3 over 2D. And we have Roman number 4. You get a third A plus a third B plus a third C. Then we have part B of the question. You have find the scalars. Find the scalars R and S such that R, A is a vector, plus S C is equals to 9B. So you can practice on that, and you find the solutions. Let me provide solutions for you in case you work it out. So we have A, Roman number 1, you should get 517. Roman number 2, so these are answers. Roman number 2, you get 21 and minus 16. Roman number 3, you get 3 and minus 5 over 6. We have Roman number 4, you should get 7 over 3 and 13 over 3. So that is, and then the other one, S is equals to 23, and R, that is B, R is equals to minus 52. Those are the scalars. So I hope you'll be able to do that. Practice on that. If you have any comment, put it in the comment section. I'll be able to respond. And that brings us to the column vector. So you can let me know if you can click down there, you get a link to the next subtopic in vectors. If you have any question or you have a topic you would like us to cover, you can always get me on 072 535 7594 or 0.36 that is 545363. You can get me on that, or you can comment there. You can also join my online math class, online math classes that I offer, and don't forget to subscribe, like this video, and also you can share with your friends. This will help me to build a strong YouTube channel, which will be able to give more revisions on math and other subjects. Thank you for watching. In this lesson, we are going to look at position vector. In the previous lesson, we have discussed the column vector, and this lesson we look at the position vector and we see the difference. So position vector, I can define it as a vector that starts from the origin. So if we draw our Cartesian plane here, let's draw our Cartesian plane. So that is our Cartesian plane. Then we have that not x but y. That is our x. We say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 1, 2, 3, 4, 5, and 6. We also have -2, -3, -4, -5, -6. We have -1, -2, -3, -4, -5. So if we pick a point, like we pick a point and say that is our point A, the 0, 0, the coordinates 0, 0 is what I'm calling, that is at the origin, is coordinates are 0, 0. That is the starting point where the x-axis and the y-axis intersect. That is where we have 0, 0 coordinate. So if you draw a line and we join it to point A, then this vector, we can say, we call the starting point as O. It is OA. OA. This is a position vector. So what I'm saying is that position vector are vectors. You can say position vectors. Vectors are vectors that start from the origin. That starts from the origin origin, and the origin 0 0. So this is the coordinates of A, 2 and 6. So we say we withdraw the components, or we can say OA, position vector OA, is equals to we say the coordinates here are 0 0, although we don't normally put that. So we say it is like the way we did with the column vector. We write it is 6 minus 0 minus 0, which is a origin. You see it gets to 2 6. So that is the position vector OA. Position vector OA. If we pick another point, we pick another point like there. We say this is our B. Then we join the origin to B. The coordinates here are 6 and 3. So normally we always put direction for vectors, so don't forget that. So we say position vector OB. So OB is equals to 6 minus 0 and 3 minus 0, which gives you 6 and 3. We can pick another point. We call it C on this side, and we call that point C. The coordinates of C are minus 6 and 5. So we can get the position vector OC is equals to minus 6 minus 0 and 5 minus 0 is equals to minus 6 and 5. So there's something you can note here. We started with OA. The coordinates of OA are 2 6. The position vector of OA is 2 6, but now in column form or vertical form. The coordinates of B are 6 3. The position vector is 6 3. The coordinates of C are, or rather, we did not complete this one. So that is let me use a correct. Let me complete that. So that is our OC. That is the vector OC. So you note that the coordinates are minus 6 5. Column vector is minus 5 6, but in column form. So you note that if you are given a point P with the coordinate x and y, OP is equals to x and y. So when you are given a point, the position vector of that point, you just write it in vertical form. You write it in vertical form. And position vector, why are we running about position vector? They are very important because you combine. We'll be working with the position vector and column vector in most of the problems in vectors. So position vector help us to identify the column vector. Let me show you that. If we join this and say this is a vector, we say this is a vector AB. Now we have position vector AB, OA, and that is OA and OB. If you recall what we did in position column vectors, we say that if you want to get the column vector AB, the alternative route is you move against the vector OA and you move along OB. So we say OB, that is not OB, OA, AB is equals to minus OA plus OB, which we say it is OB minus OA. Now we already have OA. Our OA is our OB is 6 3. Our our OA is 2, 6. 2, 6 like that is equals 2 minus 6 is 4, 3 minus 6 is minus 3. So you see now this is a column. This is a column vector. That is a column vector, and this is position vector. So very easy. Any vector starting from the origin is referred to as position vector. So I hope that one is very clear. Very short but very important concept in vectors, as we are going to see in our later lessons. We will be able to apply that. From there, let me do for you an example so that you can maybe understand better. Example, we will say draw the following position vectors. Draw the following vectors on square paper. So you have A is equals to minus 1, 2. B is equals to 2, 3. C is equals to 5 minus 2. And we have D is equals to minus 3, 4. Minus 3 minus 4. So I already have my paper here. You take your grid and you draw the Cartesian plane. So solution. Since we are required to draw, let's start with the Cartesian plane. So that's our Cartesian plane. So this is our y, this is our x. So we say it is 0, 1, 2, 3, 4, 5, 6, 7, 8. We have 1, 2, 3, 4. Let's add here. Let's add here so that our points can be. Our point can be. Let's say we have. So we have that. So we can. Okay. Before we leave there, we can put now this is our y. So we can say that is 5, so that we can accommodate. Then we have minus 1, minus 2, minus 3, minus 4, and minus 5. We have minus 1, minus 2, minus 3, minus 4. Now, recall what we have just discussed here, that when we are given a point, we write the position vector in vertical form. Same case applies here. Now, if we can say let's say this is A is a position vector, minus 1, 2, meaning the coordinates of A, this we can say like it's OA. O, it means it's minus 1, 2. So what do? We come identify minus 1, 2, it is there, and we join the point. So this is our A. So we join the points. Let me use a thicker line, and you put direction. So that is our vector A. That is our vector A. Same case applies. We go to B is equals to 2, 3. That's the position vector, meaning coordinates of B are 2, 3. So you come and identify that point. 2, 3 is here. you draw a vector. You draw the vector there. Put the direction. That is our vector B. That is our vector B. Here we go to C. Now, when it comes to C, we identify the C. C is, so we say C is equals to 5 minus 2. 5 minus 2. So it means that is position C is 5 minus 2. So we come here, identify 5 and minus 2. That is the point. We join that vector. We put that, and it means that this is our point vector C. Finally we have minus. Okay, we have 5. Finally we have minus 3, minus 4. So minus 3, minus 4 is somewhere there. We join that. So this is our, we join that point. We bring a vector here. We say the vector must always have a magnitude and a vector, so this is our vector, and this is our vector D rather. That is our vector D. So that is how you represent the vectors in the vectors given, position vectors on a square paper. So I hope that one is clear. There is not much to say about position vector except to understand that position vectors are those vectors that start from the origin, and very important. Although it may look very simple, position vector, we are going to make use of it to solve problems in advanced lessons that we are going to have. So do not ignore that. Let me give you a question that you can try. I call this one a practice question. So you are required to draw the following. Position vectors on square paper. So these vectors are A is equals to 0, 4, B is equals to 4, 3, and C is equals to minus 2, 2. So you can do that. If you are not able, you can comment about your answers in the comment section. You can also get in touch in case you have problems, can be able to assist. For this video, you subscribe to my channel. Subscribe to my channel so that we can have more subscribers to build our channel. 2, you hit the bell button. Hit the bell button. The importance of clicking the bell button is that you always get alert when I post new videos. You also like my videos. Share with your friends. Share with friends in your email or your followers, and that will be very helpful to my channel. If you want to get, you can also join my maths online classes. Then finally you can get in touch with me in case you have a question, or you have a topic you would like me to cover. So you can get me through my email. My email is teacherwamta@gmail.com. my number is 0725357594 or 0736545363. That is my number. You can get in touch with me and can see how we can help each other. So thank you for watching, and click the link below. Click the link below to get the next lesson. Thank you. In this lesson, we are going to look at magnitude of a vector. It's a very short lesson, but very important. We will be looking at magnitude of vectors in various questions involving vectors, and therefore it is good to understand how to get the magnitude of a vector. Now, to get the magnitude of a vector, magnitude, we said it is actually the size of the vector. In other books, you find the word modulus. So they mean the size, the magnitude of a vector. So what we are going to, I'm going to draw a Cartesian plane here. Let me use a black color. So we have a Cartesian plane here. So this is our y, this is our x, and we can draw a vector here. Let's draw a vector. So we have so that's the vector I want to use to describe the magnitude. We call this vector AB. We call it AB. AB is here. So we have so we say the vector is made up of, for a vector, it is defined by magnitude and direction. So I've already indicated the direction. Now, if we label if you use the units, we can draw the components of this vector. And this component, the x component, will be like that, and the y component will be like that. So we have here the component like that is actually 6. So we have 1, 2, 3, 4, 5, 6. We have 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 are the components of the vector. So we can use the Pythagoras theorem to get the using the Pythagoras theorem. Pythagoras theorem. We use the Pythagoras theorem because this angle, it is a right angle triangle. So we say AB is equals to the square root of 6 squared plus 8 squared. You remember the Pythagoras theorem. Hope so. Is equals to the square root of 64, not 64, but 36. Square root of 6 is 36 plus 64 square of 8. You get this is a square root of 100, which is equals to 10, which actually means that 10 is AB is 10 units. So this is a magnitude of AB. So we write it like this: magnitude of AB is equals to 10 units. 10 units. So that's how we get the magnitude of a vector. So in general, we can conclude, we can say that if we are given PQ is a column vector, PQ is X and Y, the general format would be the magnitude of PQ is equals to the square root of X squared plus Y squared. So we use the X and Y displacement or components as we have referred to them in our earlier lesson. So that is how you get the magnitude of a vector. You express the vector as a column vector, then you get the magnitude of the magnitude is positive. We don't have a magnitude is always positive, so we don't have negative magnitude of, because this is a real quantity. So let me do for you an example. We say example. And in my example, we say calculate the magnitude of the following vectors. Calculate the magnitude of this vector. There are more than one, so we say these vectors. So we have A is equals to 4 minus 3, and we have B is equals to minus 3 and 4. So that is B. So we can say that the magnitude of A, we use two vertical lines, is equals to the square root of 4 squared minus plus minus 3 into bracket squared. So that gives you what? The square root of 16 plus minus 3 squared will give you 9. So this gives you square root of 25, which is equals to 5. Therefore, the magnitude of A is equals to 5. Now we have the second one. We have magnitude of B is equals to the square root. We take the component minus 3 into bracket squared plus 4 squared is equals to square root of 9 plus 25. Minus 3 squared is plus 16. That gives you square root of 25, which is equals to 5, implying that the magnitude of B is equals to 5 units. So that is how you get the magnitude of a vector given the column vector or the components of that particular vector. We make use of the Pythagoras theorem, and I hope that is clear. To wind up this, let me give you a question. You can call it practice question. Calculate the magnitude. Calculate the magnitude of the following. The following vectors. So we can say PQ is equals to minus 3, 1, and we have MN is equal, I can call this B, and this is A. So MN is 8, 15. Let me write it properly. We have 8, 15. So you can do that. Give your answers in the comment section. You'll be able I'll be able to see. So that brings us to the end of that lesson, or that very short lesson. So just to mention, you subscribe, please subscribe to my channel. Subscribe to my channel. That should be channel. Like my videos if they are helpful. Hit the bell button the one that looks like a bell. Can I be able to draw it? It is like that. No, it is like that. That one. The importance of hitting that bell is that whenever I post a video, if they help you, then you'll be notified in your channel or in your email. Then you can join my online maths class. That's not online classes, and we will be able to revise more on maths, on other subjects. Finally, if you want to get in touch with me, my email is teacherwamta@gmail.com. You can get in touch through this number 0725357594 or 07365453. This is 5363. If you have any question, or you have a topic that you would like me to cover, you are free to do so, or put it in your comments. And thank you for watching. In this lesson, we are going to learn how to get midpoints of a vector. The midpoint divides the vector into two parts. Midpoint divides a vector into two equal parts. So let's consider this. We have a Cartesian plane here, right? So we have that different color here. Let's draw the Cartesian plane here, and this is the x-axis. So that's so we say this is our y, and this is our x. Consider a vector. Which is let's use that from here like that. This vector, the direction is that, and we say this vector is a. We say this is a, and it is -1. The coordinates of a. Let's write it properly. A -1 and 6. So those are the coordinates, and b, we have 5, 2. So we can draw the position vectors. We have that will give us position vector OA. This will give us position vector OB, and we assume that this is the midpoint. So we draw another vector there, OM, which we can draw it as a dotted line like that. Of course, this is the origin. That's the origin. Now, if you are given that, we say using vector method. Since we are saying that M is a midpoint of that, the vector OM is equals to, this is our vector OM. We say it is equals to, you follow this route, OA plus AM. So we say it is OA plus a half AB. So we already have AB, we have OA, so we need to find AB. I'll do it separately here. So AB is equals to, we say it is 5 minus 1, and 2 minus 6. So that to give us our AB, which is equals to, we say our AB is a half 5. So that will give us 6. That will give us 6 and minus 4. So that is our AB. We come and replace our AB with OM. So this will be OA. We use the coordinates minus 1, 6. That is OA plus a half 6 minus 4. So this will give you what? This is 1 minus 1, 6. And this plus 3 minus 2. So that will end up with is equals to minus 1 plus 3. That will give you 2 and 4. So that is a position vector. That is OM, position vector OM, implying that since we have OM, the coordinates of M are 2 and 4. 2 and 4. So that's how using the vector method. Now, using the same example, let's say we have now, let's get a general formula. So consider this. We have a vector. We have a here vector. Here we put it. We have a vector. That is vector, and we say it is A, B. The coordinates of A are x1, y1, and here we have x2, y2. Those are the coordinates. We say, okay, we can get the components of A. We say it is we say that is the origin. So that is O. So that is vector OA, and that is vector OB. Assume that this is the midpoint, so we can draw a line there, which is represent the midpoint. Can use a dotted line like that. So draw that diagram. The coordinates of the origin are 0, 0. So we can say now here we want to derive a general format. So OM is equals to OA, just like we have done with the other one. OA plus AM, where we have OA is A as indicated here, and this is B, plus AM is a half AB, but AB is equals to B minus A. So we can replace this. So we say this is equals to A plus a half A, not A but B minus A. So when you open the bracket, you get A plus a half B minus a half A. A half A, A minus a half A, that will give you a half A plus a half B, which we can factor out a half, and we are left with A plus B. Now, once you have that, we have or you can still write it A plus B divided by 2. So once we have that, we already have A is equals to X, that is X1, Y1. And we have B, using the coordinates, we have X2, Y2. Therefore, we can come here and say, then it means M is equals to X plus, that is we say that, just a minute, we say A, now we bring this this here, we say A plus B, which is the midpoint we have worked out, divided by 2 is equals to a half, and we say it is X plus X1 plus X2 and Y1 plus Y2. So this means that you have this is equals to, when you open the bracket, then you have, since that is our our m, we say our m, then it is x plus xy plus x1 plus x2 divided by 2, and y1 plus y2 divided by 2. What am I trying to say? That if you are given two coordinates of a point, then we use those coordinates to get the midpoint. For example, if we have A is 2, 7, and B is 4, 9, then we can say if m is a midpoint, m is a midpoint, then we say m is 2 plus 4 divided by 2, and 7 plus 9 divided by 2, and that is give us 2 plus 4 is 6, 6 divided by 2 is 3, and we have 7 plus 9 is 16 divided by 2 is 8. So that is the midpoint. So this becomes an easier way of getting the midpoint of a point. You add the two corresponding values of x, you divide by 2, two corresponding values of y, you divide by 2, and you get the midpoint. So I hope that is clear. Instead of following the vector method, then this one is easier for you to follow. From there, we look at an example. We say find the coordinates of the midpoint of AB in each case. In each of the following cases. So we have our A. We have A, the coordinates of A are minus 4, 3, 4, 3, and we have our B, this is our B, is 2, 0. Then we have B, our coordinates of, we have A, we have 0, 4, and we have B, 0, minus 2. So we want to find the midpoint of these 2 points, A and B. So we start with A. We have said that the midpoint, M, we say it is minus 4 plus 2 divided by 2, and 3 plus 0 divided by 2, and that will give you what? Minus 4 plus 2 is 2, 2 divided by 2 is 2, is 1. Then we have 3 plus 0 is 0, and divided by 3 plus 0 is 3, divided by 2, you get 1.5. So that is the midpoint of part A. Part B, then we say the midpoint, we will say it is 0 plus 0 divided by 2, and we have 4 plus minus 2 divided by 2. So this will be 0 divided by 0 is 0. 4 minus 2 is 4 minus 2 is 2. 2 divided by 2 is 1. So that is the midpoint. So you see how easy it is to get the midpoint. I hope that is clear. You can check on other questions from your textbooks, and you will be able to find the midpoint of a point of a vector. Now I give you a practice questions. You can try this, and we are told in the figure below, OAB is a triangle. A is the point. that is 2, 8, and B is a point is a point 10, 2. Then you are told C, D and E are midpoints of OA. We have midpoints of OA, OB, and AB respectively. Okay, so let's have the figure. So we draw the figure. Our figure is like this. We have that is our X. So we have this is our X, Y, this is our X. Then we have our vector here. We have a vector there. Let's draw a straight line. We have our vector there. So this is A. This is a vector AB. So this is A. Coordinates of A are 2, 8. Coordinates of B are 10, 2. Then we can draw the corresponding position vector of OA and OB. Then we can join the midpoint. So that is a midpoint, that is a midpoint, and this is a midpoint here. We label our diagram. So this is labeled A, B, C. We have D and E. So those are the points. I think that so we have part A. Find the coordinates of C and D. Find the coordinates of C over the coordinates of C and D. C and D. Part B, you are told find the length of the vectors. Find the length of the vectors CD and AB. So that's a practice question you can try. Okay, we have covered how to get the magnitude or the length. This is the same as the magnitude, modular size as the same. We have covered that. If you have not seen that, you check one of my videos. You can check the video, the series on vectors 1. You work it out. You can give your answers in the comment section. But let me give you the answers if you can confirm. So for part A, you'll be able to get the coordinates are 1, 4. And that is 1, 4. Then we have the coordinates of part B. Part B. These are the coordinates of those are the coordinates of C. Then we have D. The coordinates of D are 5, 1. Then we have part B. You have the magnitude of length of so we have I've worked out CD that I have gotten is equal to 1 unit. I think you can check AB we get that I think you work out B. I have not worked it out, so that is a question you can try. So if you get this, then you know that you have understood what we have covered now, and you can try other questions. To wind up, if you subscribe to my channel, to my channel. That will make my channel grow. Like the video, share, and comment how you have found the video, if it is okay, if it is helpful to you. Hit the bell button. This is important because it will alert you whenever I post a new video. This icon that looks like this, that is the bell. So you click it, so like that, and that's how you get that. If you want to get, you can join my online math classes. This is classes. If you want to get to me, you can write an email, teacherwamta@gmail, one name, teacherwamta@gmail.com. My number, in case you need any help, can get me through this number, 0725 357594 or 0736 54 5363. So that's if you need anything. If you want me to do a topic that gives you problems, just let me know. And thank you for watching. Welcome to today's lesson. And in this lesson, we are going to look at collinear points. So the word collinear means points that are, or collinear points means points that rise on the same straight line. We can demonstrate that using the Cartesian plane. So I'm going to draw a Cartesian plane here. So that is this is our y-axis, and this is our x-axis. Now we label our Cartesian plane. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Can get to that point. Now we can identify 3 points. For example, we can take 4 and 4. We say that is our point A. Then we say 7, 5, 7, 5. That point, that is our point B. And we have 10, 6. We have 10 and 6. So we can call that point C. Now, if you take a ruler, you join the 3 points, you find that they form a straight line. So we say that in this case, we say A, B, and C are collinear. That means that they lie on the same straight line. Now we can take other points. For example, we can take that point and call it this point here, we call it P. We can take another one here, we can Q, and we can take another one here, we can say R. So you find that P, Q, and R, you cannot join a straight line. If you join a line, then you come up with, you join the 3 points, then you come up with that kind of line, 2 lines. So we say P, or rather we say P Q and R are not collinear. They are not collinear. So that is what we mean by collinear points. Points that rise on the same straight line. But now we don't have to draw the points on the Cartesian plane all the time to show that the 3 points are collinear. We can be able to verify by connecting the 3 points whether they are collinear or they are not collinear. Let's start with A, B, let's start with A, B, and C. You say, let's write the coordinates. The coordinates of A are, we have 4, let me check. We have 4 and 4. Then we have our B is 7 and 5. We have our C is 10 and 6. The y component is 6. Now, what we do, we have already discussed the column vector. So we can be able to get B is equals to AB, we get it is 7 minus 4, that is the x component, and 5 minus 4. So that will give us what? This will give us 3 and 1. So that is the column vector AB. If you don't know how to get the column vector, you can check my lesson on how to get column vector and also the position vector. Now again, we can be able to say AC. We can get the column vector AC, that is using AC, A and C. So we say it is 10 minus 4. 10 minus 4 and 6 minus 4. So that will give us what? 10 minus 6 is equal 10 minus that is 10 minus 4 is 6, and 6 minus 4 is 2. So that is a column vector. Now the column vector AC, we can factor out 2 and we will be left with when you factor out 2, you'll be left with 3 and 1. Now you find that this is the same vector as this one, and therefore we can say AC, or this implies that AC can be written as 2AB. 2 can be written as, AC can be written as 2AB. When you are able to connect the two vectors A and B with A and B, and we have a common point. The common point here is A. A is common, and you have expressed AC in terms of AC in terms of AB. That is, AB is twice the length of AC, or AC is twice the length of AB. So we say that when you are able to express a vector in that format, we conclude that the 3 points are collinear. The 3 points are collinear. Now, if you try to do that with P, Q, and R, let's try that. Let's try that. So what I have done is I have created another page so that we remain with our other page. Now what we do is we get PQ. PQ is equals to the coordinates of P are 1, and 6. The coordinates of Q are 5 and 6. Hope you know how to get the coordinates. We get the x component and the y component. And finally, we have our R. We have our R is 7 and 9. So we can get PQ. It is 6, not 6 but 5. It is 5 minus 1. And we have 6 minus 6. That will give us what? It is equals to 4, 0. So that is a column vector PQ. Let's get PR. PR is equals to our PR. We say it is we get the coordinates of R, and we say it is 7 minus 1, and we get 9 minus 6. So we say this is equals to 6. 9 minus 6 is 3. You see now, there is no way we can be able to write PQ in terms of PR. Even if we factor out 3 here, we will be left with 2 and 1. And you see, this is not, they are not equal. They are not equal. So we cannot express PQ in terms of PR. So we say P, Q, and R, PQ and R are not collinear. Hope you get that. PQ and R are not collinear because we cannot be able to express PQ as a scalar multiple of PR. If we go back to our question here, you can see here we have expressed AC is a multiple scalar of AB. Remember what we said about the scalar multiple. 2 is a scalar. 2 is a scalar. So this means that is why we concluded that AC and A, B, and C are collinear. You must be able, for you to conclude that 3 points are collinear, you must be able to connect, to express one vector as a scalar multiple of the other. Maybe somewhere we can, if we since we are saying AC, we are saying just to note that since we are saying AC is equals to 2AB, if we divide by 2 here, you divide by 2, you find that AB is equals to a half AC. You see now, a half here is a scalar. This is a scalar. So we can express AB as a scalar multiple of AC. And they share a common point A. So that is how we conclude that 2 points are collinear. We cannot express PQ in terms of we can say why, because this is because we cannot express express PQ in terms of PR I hope that one is clear on collinear points. We can try some other points. Let's say we have now, without the Cartesian plane, how can we be able to show that 3 points are collinear? So we can say find out whether the following points are collinear. Let's say we have A. Our A is 1, 2. Our B is 6, 3. And our C is, can say 11, 4. Now, we don't have to draw the Cartesian plane to prove that these 3 points are collinear. What do? We can get AB is equals to, AB will be 6 minus 1 and 3 minus 2. So that will give us what? 5 and 1. We can express AC. AC is equals to 11 minus 1 and 4 minus 2. So that will give us what? This will give us 10 and 2, which we can write that we can factor out. I can factor out 5, 2 rather, and we are left with 5, 1. When you open the bracket, you multiply. If you multiply 2 times 5, you get 10. If you multiply 2 times 1, you get 2. So we have not changed our vector. Since now this vector here is AB, then we conclude that we can write AC is equals to 2AB. So concluding that the 3 points, are collinear. Meaning what? They lie on the same straight line. And if you plot them, you'll be able to prove, or you'll be able to see that they lie on the same straight line. Another example is that if we take point P, we say it is 1, 8. Q, we say it is 6, 5. And we have PR is 11, 2. Find whether they are collinear. So what do? We express. We can start with. In fact, we can also say PQ is equals to. It is 6 minus 1 and 5 minus 8. So that will give us what? 5 minus 3. We can get PR or even get QR. Let's try QR. QR is equals to 11 minus 6 and 2 minus 5. 2 minus 5. So this is equals to, that will give us 5, and this is minus 3. So you see, now these two vectors are the same. So we can say PQ is equals to QR. Well, you see now they share a common point. Q is